Students, here you will be learning about the next type of symmetric channel called as binary erasure channel, or also called as BEC, binary erasure channel. So what is binary erasure channel? Okay, so here the best way to explain, like I said before, is by using the channel diagram, right? So binary erasure channel means, okay, you heard there's a word binary over here, which means that transmitter has two symbols or two messages. I'm going to represent that using these two dots. Okay, the transmitter has two symbols or two messages. This is for message 0 and this is for message 1, right? Now at the receiver side, that's a difference. In the receiver side there are two, but there are three symbols at the receiver. The receiver will be receiving three messages. Okay, three messages, three symbols, and that is the receiver side. The symbols are 0 and the symbol is 1. Okay, and there's one more symbol called as Y. Now you will learn what is the symbol Y, what is the use of symbol Y. You will learn later. Okay, what is the symbol Y. So now I'm going to draw this channel diagram. So these are the two symbols. That is, here the number of transmitter symbol is equal to 2 and the number of receiver symbol is equal to 3. In other words, M is equal to 2 and N is equal to 3. Right? The number of transmitted symbols is 2 and the number of received symbol is 3. Now I will tell you how the working is. If 0 is transmitted and if there is nothing wrong with the transmission, if no error occurs and 0 is transmitted, then 0 is received. Okay, let that probability be Q. Let the probability be Q. Okay, 0 is transmitted, 0 is received. Likewise, here also, if 1 is transmitted and 1 is received, if no error takes place, then if 1 is transmitted, then 1 is received. That is Q. Okay, so that means Q is the probability of correct transmission. Q. Now, what will happen if an error occurs? This is where the difference comes. What will happen if an error comes, if an error takes place? If an error takes place, right? If an error takes place, then instead of when 0 is being transmitted and when an error takes place, the receiver will not receive 1. Instead, the receiver will receive the signal called as Y. If the error takes place when 0 is transmitted and when an error takes place, instead of receiving 1, the receiver will receive another signal called as Y. Okay, and likewise, if 1 is transmitted and when an error takes place, then the receiver will not receive 0, instead it will receive the signal Y. That probability is considered as P, which means P is the probability of error. Okay, P is the probability of error. So this is the only difference between the binary erasure channel and binary symmetric channel. That is, if an error occurs, the receiver will not receive the wrong transmission, will not receive the wrong symbol, but it will receive the symbol called as Y. Y is called as the rejection symbol or the erasure symbol. That is why, because the reason is, if an error occurs, okay, when the transmitter is transmitting 0 or 1, and when an error occurs, the receiver will receive this signal. If an error occurs, if there is something wrong in the transmission, then the receiver will receive this signal, and if it receives this signal, then that decision will be rejected or that decision will be erased. That is why this is called as binary erasure channel, because here the receiver is protected from the wrong transmission. The receiver is protected from any kind of wrong communication. Because if an error occurs, the receiver will not receive the wrong symbol, but instead it will receive the symbol called as Y. This is called as the binary erasure channel. Okay, this is what this is called as the binary erasure channel. So how do we write the conditional probability P of y by x? how do we express the we know that, right? From the channel diagram we can express the channel matrix P of y by x. So how do we express P of y by x? So P of y by x, let me write that in full form. P of y by x is written as, so here let me see, there are 3 received symbols and 2 transmission symbols, which means there will be 2 rows and 3 columns, right? So let me see. So which means the first element will be when y is equal to 0, when x is equal to 0. The second element will be probability that y is equal to y when x is equal to 0. That is for this one. Then the other one is probability that y is equal to 1 when x is equal to 0. Okay, when x is equal to 0, that is the third element. Now this is the first row. Now on the second row it is probability that y is equal to 0 when x is equal to 1. The other one is probability that y is equal to y when x is equal to 1, and then probability that y is equal to 1 when x is equal to 1. So this is the matrix. So let me see, which means the value of P of y by x is, so what is the probability that when y is equal to 0 under the condition that x is 0 is transmitted? It is Q. Now what is the probability that the received symbol is y when 0 is transmitted? It is P, error probability P, right? And what is the probability that y is equal to 1 when x is equal to 0? There is no probability. That will never take place, which means that when 0 is transmitted, 1 will never be received by the receiver. If 0 is transmitted and if it's a correct transmission, 0 will be received. If 0 is transmitted and if the wrong decision is made, then y is received. The small letter y is received. So therefore, this probability is equal to 0. Likewise, what is the probability that y is equal to 0? That is the receiver received 0 when 1 was transmitted. The receiver received 0 when 1 was transmitted. There is no probability, right? Such an event will not take place. So therefore it is 0. What is the probability that the small letter y is received when 1 is transmitted? It is P. What is the probability that y is equal to 1 is received when x is equal to 1 is transmitted? That is Q. See, this is the equation for P of y by x. This is the equation for P of y by x. As you can see, this is now this is all. Now you know why this is also considered as a symmetric channel, because this is P of y by x. So we should compare the rows, right? And both the rows are same except for the position of the elements. So therefore, from here I can say that h of y by x, right? H of y by x is equal to the entropy of any one row. So I will take any one row. Okay. So I'll take this row, which means the entropy is equal to P log 1 by P plus Q log 1 by Q. This is the equation for h of y by x. Okay. Now, next thing what I'm going to teach you is very important. Alright. See, you have already understood the working of this binary erasure channel, right? That is, the receiver, the transmission will transmit 0. If it is correct transmission, then the receiver will receive 0 itself. And if it is a wrong transmission, if an error occurs, or when the signal is being propagated to the channel, then y is received by the receiver, right? So now the thing is, anytime when the receiver receives the symbol y, anytime when the receiver receives the symbol y, then that decision is rejected or that decision is erased, right? It does not take into account that decision anymore, because this decision is useless, because from here the receiver understands that the wrong error has taken place. So that means the receiver will reject this decision. So which means the reason why I'm talking about this is that because we know the equation of mutual information, right? There are 3 equations of mutual information, right? there are three equations. That is I of x comma y is equal to h of y minus h of y by x. This is one of the equation of mutual information. The thing is, you cannot use this equation when you are finding the mutual information of this channel. You cannot use this equation. The reason is because this equation has h of y inside it, and this h of y means the entropy of the receiver. But like I said, the entropy of the receiver will not be the same as what the information provided by these three symbols, because the information provided by this symbol is rejected. Since the information is provided by this symbol is rejected, then we cannot use h of y as equal to probability of 0, probability of receiving 0, log of 1 by probability of receiving 0, probability of y, log of 1 by probability of log y, plus probability of receiving 1 plus log of 1 by probability of receiving 1. You cannot apply that decision, we cannot apply that equation to h of y. The reason is because the information provided by this specific symbol is actually rejected. That is why you cannot use this equation. You cannot use this equation when you are finding the mutual information. In effect, you cannot use the equation for any mutual information which has h of y inside it. Which means only one more equation is left behind to find the equation of mutual information. That is I of x comma y is equal to h of x minus h of x by y, which means this is the only equation left behind from where you can find the correct mutual information. You cannot find you cannot use the equation I of xy is equal to h of y minus h of y by x. You cannot use that equation. Also, you cannot use this equation also. That is I of xy is equal to h of x plus h of y minus h of xy. You can't use that equation also. You can only use this equation, because in both the equations h of y is inside it, and you cannot trust the value of h of y, because this information, any information provided by this symbol, provided by this decision, is rejected. So that's why you cannot use h of y in anywhere. You cannot use h of y anywhere in this derivation, which means this is the only equation you can use. Which means I need to find h of x and h of x by y. Which means to find h of x, I need to find p of x, and to find h of x by y, I need to find p of x by y. And all I have is p of y by x. That means from p of y by x, I have to find p of x and p of x by y, right? So now the procedures are basically very simple, right? So what I'm going to do is that just like in the binary symmetric channel, I'm going to say that let alpha be the probability that 0 is transmitted. Let alpha be the probability that 0 is transmitted. Okay, in that case, then 1 minus alpha is the probability that 1 is transmitted. Or in other words, p of x is equal to 0 is equal to alpha, and p of x is equal to 1 is equal to 1 minus alpha. Or in other words, p of x is equal to alpha comma 1 minus alpha. This is the equation of p. This is the signal. This is the matrix of p of x. So now I found my value. Now I found what is p of x, right? P of x, and now I have p of y by x, and now I have p of x. Remember, what I need is p of x and p of x by y. So now I already found p of x. Now I need to find p of x by y, right? So now I have p of y by x. So what you can do is, you already know the conditional probability equation, right? That is p of y by x is equal to p of x comma y by p of x. Or in other words, p of x y is equal to p of xy is equal to p of y by x into p of x. right? P of y by x into P of y, which means we already know, so which means in other words, P of x y, P of x comma y is nothing but, so how do we find the value? That is nothing but you multiply P of x, the first element of P of x, alpha, you multiply that with the first row, you multiply with the first row of P of y by x, and then you take the second element 1 minus alpha and you multiply that with the second row of P of y by x. Or in other words, I use another pen so that you can understand the difference between these two. Okay, so which means P of xy is equal to, let me see, q into alpha, okay, other one will be P into alpha, and the other is 0 into alpha is 0. Okay, now in the second row, the second element is 1 minus alpha, right? So 0 into 1 minus alpha is 0. Then P into 1 minus alpha is P into 1 minus alpha. Okay, and the other one is Q into 1 minus alpha. Q into 1 minus alpha. There. I found the value of P of xy. So now, like I said, what I want is, don't forget, what I want is P of x by y, right? I need is P of x by y. That is what I need. And what is P of x by y? We already know the equation for P of x by y, right? P of x by y is equal to P of xy by P of y, which means I already have P of xy, so it means now I need to find P of y. And how do I find P of y from P of xy? Simply add all the elements column wise. So in other words, P of y is equal to adding all the elements column wise of the joint probability matrix, column wise. If you add all the row wise, you will get P of x. Likewise, if you add column wise, you will get P of y. So P of y is equal to, first element is Q alpha plus 0, which is equal to Q alpha, comma. The second element is P alpha plus P into 1 minus alpha. P alpha plus P into 1 minus alpha. This P alpha and minus P alpha will cancel each other, which leaves behind only P. That's the second element. And the third element is 0 plus Q into 1 minus alpha, which is Q into 1 minus alpha. So now you found the value of P of y. Okay. So now you found the value of P of y. And so now you are going to find, so we know that P of x by y, right? We know that P of x by y. Let me write that equation. I'll use another pen. That is P of x by y. P of x by y is equal to P of xy by P of y, right? Which means, how do you do this? Which means we need to, this is a P of y, which means we need column wise, which means we need to divide every elements column wise. We divide the first element in the first column, we divide the second column with the second element, we divide the third column with the third element. That's how it works. Or in other words, let me just expand that for you so you'll be able to understand very clearly. That's what I meant is, to find it, all you need to do is, okay, just hold on, okay. So which means, here it will be Q alpha by Q alpha, right? And then the other will be 0 by Q alpha. The third element is, the second element is P. So which means divide the second column with the second element, which is nothing but P alpha by P, okay, and then also over here it will be P into 1 minus alpha by P, and then as for the third column, divide the third column by the third element, right? So which means you get 0 by Q into 1 minus alpha, and then here it will be Q into 1 minus alpha by Q into 1 minus alpha. Okay, you don't have to write the whole thing in the book. All you need to do is just simply, you can do the calculation mentally. That's more than enough, right? So here Q alpha by Q alpha is 1, P alpha by P is equal to, P and P gets cancelled, so it will be alpha. 0 by anything is 0, 0 by anything is 0, P and P gets cancelled, so it will become 1 minus alpha. And here Q by 1, here both the numerator and denominator are the same, which means the ratio is 1. This is P of x by y. This is P of x by y. Okay. So now I have found P of x by y. So now I can directly find my h of now I can directly find my h of x, and I can find my h of x by y, right? So now you know how to find all this, right? Now it's very easy for you. So now let's find the values. Okay, the equation for h of x by y. H of x by y is equal to sigma k is equal to 1 to m sigma j is equal to 1 to n P of xk yj log of 1 by P of xk by yj, right? There is no shortcut method for this because this is not a symmetric channel. You see, P of x by y is not symmetric. Both the rows and elements are, both the rows, the first row and second row are different from each other, which means you have to use the long method, this method, that is using this and this. Only you can find this. So let's find it, alright? So here it will be, let me see, what is the first element? Let me see, the first element is Q alpha, right? So Q alpha is the second, is a first element, and here 1 by, this is the second element, which means it will be Q alpha log of 1 by 1, right? Which is 0 basically. It's okay. The second one will be P alpha, right? P alpha. So it will be P alpha log of 1 by, what is the probability over here is alpha over here, okay? Now plus, and what is the second thing here? It will be 0 into anything is 0, so no need to calculate that. Again over here also 0 into anything is 0, so no need to calculate that. Then you have this one, this is P into 1 minus alpha. So P into 1 minus alpha into log of 1 by, what is the corresponding element? It is 1 minus alpha, 1 minus alpha, okay? Plus, and over here also we have Q into 1 minus alpha into log of 1 by 1, which is basically 0. So here what you get over here is P alpha log 1 by alpha. Let me write that again. Therefore h of x by y is equal to P alpha into log of 1 by alpha plus the other one is P into 1 minus alpha. P into 1 minus alpha log of 1 by 1 minus alpha, right? So we got that much. Okay.